Hello again. How are you? How are you doing? It's me, Mourad Sultan Ezouidi, the pioneers in methods. Okay, with you. Okay. So today, my professors, my learners, teachers, and colleagues, we have the honor to explore a groundbreaking advancement in the field of algebra presented by Professor Mourad Sultan Ezouidi, a mathematician whose deep research in the polynomial equation has led to powerful new method of solution. Means here in this example that we are going to solve it, which is 11 degree from equation. It's very hard. No one before solved this kind of nth degree from equation as Mr. Mourad Sultan Ezouidi, a Tunisian researcher in the field of solving nth degree from equation and nth linear degree from equation. Okay. So, contrary to the classical conclusion of Abel theorem, because that contrary to the classical conclusion of Abel's theorem, which said that there is no general solution by radical 4 polynomial of degree 5 or higher. Here it is. Professor Ezouidi introduced a novel theoretical framework that allows the exact solution of specific high degree polynomial equation, including those of degree 11, 12, 13, 14, 15, 16, and beyond, using using what is now known as Ezouidi theorem. We will solve an 11th degree polynomial equation with exact roots. Welcome again, welcome again, my learners. Okay, welcome again for this special session. We are not just solving a polynomial, we are challenging mathematical history itself. According to Abel's theorem, general solution for fifth degree and higher polynomial are impossible using radical. The door was closed before mathematicians stopped searching, but Professor Mourad Sultan Ezouidi says otherwise. Through the power of the Ezouidi theorem, a new path is revealed, one, one that leads us beyond the classical limit into the exact algebraic solution of even the 11th degree polynomial equation. Here it is. Mourad Sultan Ezouidi start explaining how to dive into the structure, into his structure, and let's say derive all the coefficients of this new 11th degree polynomial equation. Today we'll demonstrate this, not with approximation, with or not with guesswork, but with precise and exact roots. Abel said no, okay, but Ezouidi says yes, it's solvable, redefining the limits of algebra. Today, my professors, we make history. I will show you an equation that exposes the failure of all the classical methods, including Abel's theorem, and reveal their exact roots using my own method or my own theorem that call it Ezouidi theorem. Our objective today or our target is to demonstrate the failure of classical algebraic methods into solving or in solving certain high degree polynomial equations and to introduce Ezouidi theorem as a breakthrough that delivers exact symbolic solution where tradition fails, means where classical method fail. And I will go to prove or I will prove it right now. Okay. So we start. Let me guide you, my professors, through the lens of Ezouidi, Mourad Sultan Ezouidi, where structure and symmetry lead the way. This is not trial and error. This is systematic. This is exact and it's reproducible. So here we are not relying on numerical roots. We are not relying on approximated roots. We are not relying on guesswork or guessed roots like Newton strategy or method. We are pulling the exact algebraic roots from the very fact of polynomial equation. And you should note that how classical method failed. Note that Note how classical algebra hurts her. It has no tools left because it's now easy to solve 11 degree from equation using classical methods. But the theorem continues the journey. The classical road ends with Abel's barrier, but I build a new bridge and I will walk you across now. Okay, so let's dive into the structure and start solving, let's say, solving our 11 degree from equation. Now I'm going to share the lecture with you so that you can see the whole lecture and get benefited from the Professor Mourad Sultan Ezouidi. So this is my polynomial to the power 11 that I'm going to start with this one. Okay, you can see this one is our 11 degree from the equation that we are going to work with now. Okay, so get ready, my professors and teachers. Okay, and colleagues, and try to solve with your Professor Mourad Sultan Ezouidi, the Canadian researcher in the field of mastering the solution of n-dimensional equation, and the professor in the field of mastering the solution of nth degree linear equation. So that will be 100% persuaded and convinced that classical methods now are uh, obsolete. Okay, this is a new word in English. Okay, obsolete. Okay, so I will check its pronunciation again. What is obsolete? Obsolete. 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 Meaning that classical methods are now considered as obsolete methods. Okay, obsolete. Okay, we say obsolete. So here in our example, my professors, you can see this is going to the power 11 in front of you, okay, and try to solve it, okay. So this is b of x equal x raised to the power 11 minus x raised to the power 10 plus 55 divided by 11 squared x raised to the power 9 minus 165 x raised to the power 8 divided by 11 cubed plus 330 x raised to the power 7 divided by 11 raised to the power 4 minus 461 times x raised to the power 6 divided by 11 raised to the power 5 plus 456 x raised to the power 5 divided by 11 raised to the power 6 minus 315 x raised to the power 4 divided by 11 raised to the power 7 plus 145 x cubed divided by 11 raised to the power 8 minus 40 x squared divided by 11 raised to the power 9 minus 85. This is plus negative, we give you now minus immediately. Okay, so it will be minus 85 divided by 11 raised to the power 10 times x plus 90 over 11 raised to the power 11. Here, Abel's theorem does not work. Okay, it's considered as obsolete. Obsolete, obsolete theorem. And the rational root theorem also is considered as obsolete, obsolete method, obsolete theorem. And the second Newton method is considered now as obsolete method. Okay, means has no sense. If you want to apply these methods, these classical methods, it means that you are going to uh, get inside an empty circle. Okay, plus what we called this is we call this minus, my right here minus, okay, minus, then I'm going to ignore the negative sign in front of 85. Okay, this is, so this one can be written like that. Why? Simply because this is L9 is negative 85 plus negative u, okay, times x plus, in fact, is minus 90 divided by, is minus 90 divided by 11 raised to the power 11. This is the last term. and there is a negative sign here. You see negative plus positive. Negative times negative is positive. So now this is the original 11-degree polynomial equation. Can be written in its standard form, x into the power 11 minus L0 42 x into the power 10 plus L1 of 42 x 11 minus L2 42 x into the power 8 plus L3 for the q x into the power 7 minus L4 of all the q times x raised to the power 6 plus L5 42 x raised to the power 5. Okay, minus L6 of 42x equals 4 plus L7 of 42x cubed minus L8 of 42x squared plus L9 of 42x minus L10 of 42. So I will use my theorem to solve this one to the power 11. Those who are now, those who are still watching and joining the lecture, type this and put into ChatGPT, Forum, or DeepSeek, will never find the solution. They will try to use middle method, rational theorem, approximated method. Then at the end, they will tell you that it's impossible to solve this with to the power 11. This is AI, artificial intelligence. But here, Mourad Sultan Ezouidi uh, uh, invents, let's say, new theorem that can deal with this high degree from the equation. So let's start. Now you can see that this is 11 degree from equation. I'm going to find the new 11 degree from equation related to SR42, relative respectively to LR42, where R belongs to -1 up to 11, -1 means uh, 10. Okay, so here let's dive into the structure, my professors. Okay, and you can see that this is not just about one equation. This is about changing how we understand algebra itself. Okay, so the theorem rewrites what was believed to be a dead end. We bring life into what was once shadow. Okay, so this method, my professors, is not only powerful, it's a new chapter in the story of mathematics. Okay, so here let's dive into the structure or into the theorem of Mourad Sultan Ezouidi. This one that is written in front of you, and put k equals 0, we obtain that s minus 1 is going to be equal to 1. This is by convention, or replace, just put k equals 0 here. And what else? Now to find s0, just dive again into the structure and replace k with 1, and we'll get that as 0 equal n minus 1 between parentheses of course times 0.42, which is going to be equal always 0, means that uh, s0 is the sum of the x roots of this new 11 degree from equation that I'm going to write in terms of s subscript k minus 1 over the r. Okay, that corresponds to the original 11 degree from the equation. Okay, so here my professors is, let's say, obsolete. Okay, meaning that those who are still using classical method, I advise them that these methods are considered as obsolete. Okay, obsolete, obsolete, obsolete. To say obsolete means has no sense. Okay, no matter if you are going to use, but we never find exact roots, as the Professor Mourad Sultan Ezouidi will explain it right now. Okay, we'll explain it right now, okay, not right now. Okay, here as one of my kids just dive into the structure of this and put k equal to, you obtain that s1 is equal to this, and make your substitution, you find that s1 is equal to no. We continue here, my learners, professors from all over the world, from all over the universities, okay, in this whole world. It's now time to get rid of classical methods because they are considered as obsolete. Okay, obsolete. Okay, it's a good word, obsolete. Allah, it's a good word. Okay, so we can say obsolete, or let's say methods that have no sense, methods that have that uh, make no sense for you. Okay, but this structure, the new theorem of the Professor Mourad Sultan Ezouidi, makes sense for you. makes sense for you simply because you will see in the explanation that every term speaks, that every coefficient has a message, and Zwidi method knows how to listen. The method of Zwidi knows how to listen. Okay, how to listen to these messages of the coefficient of the new differential equation. That's the secret here. Okay, if classical method close the door, okay, now we can say that, or we can say that mathematics still holds seconds, but we, the Professor Mourad Sultan Ezouidi, hold the key. Okay, so we continue. We call that dive into the structure and put k equal 3. We'll obtain the standard formula, the general formula that will give you the third coefficient of the new level degree equation. So we calculate this. We found that S2 is going to be equal to 0, my professor. Okay, so we continue. We call that. I'm going to dive again into this structure and put k equals 4. Then we derive that S3 is equal to the following. Okay, S3 is equal to the following. So let's dive into the structure. You can see that every term speaks. Okay, even the structure itself speaks about how classical methods like Abel theorem, like Isaac Newton method, like approximation method are all considered as obsolete. Obsolete. Okay, we put the obsolete. Okay, good enough. So we call that now as 4. My professors as 3. My professors is that. This is the formula. I will give you as 3 for any degree from equation. Travel wherever you want. Okay, study whatever you want. This is the formula. That will give you the new nth degree from equation that corresponds to the original 11 nth degree from equation. And this equation, this is the new human degree equation, in fact, is a unit. Okay, is a unit for the nth original degree from equation. Okay, so we continue. We call that here we dive into the structure and replace k with 4 to obtain S3. And we calculate S3 that, and we found that is in fact is equal to an L. Okay, we continue. We continue. So we can say this is not just about solving or mastering the solution of one single equation. This is about changing how we understand algebra itself with the Professor Mourad Sultan Ezouidi. So Ezouidi method here, or Ezouidi theorems, rewrites what was believed to be a dead end. We bring light into what was once a shadow. Okay, we continue. Now we want to find S4. Here in this example, S4 has to be different to 0. Okay, I'm going to dive into the structure. My professors, teachers, colleagues, and learners, I'm going to, let's say, dive into this structure, okay? And then we are going, we will derive the fifth coefficient when k equals 5. So I will obtain S4. Here, S4 is equal to minus 1, okay? Here, S4 is going to be equal to minus 1. Just put use the calculator, okay? And figure out the value of S4. This is, we give the fifth coefficient of the new 11th degree from the equation that is written in terms of x subscript k minus 1 of all the cubes, okay? So we dive again into the structure and replace k with 6. I want to find S5 here. So S5 here, my kids, I will just apply the formula. This is the formula that is written in its standard form, and this is the substitution. So this calculation, let's say in this with no, or uh, adds up to a no. Okay, we dive into again the structure and put k equals 7. I will just use the Ezouidi theorem, and I replace k with 7. I obtain this one. Expanded this in terms of binomial coefficient and the highest power of the polynomial and the coefficient the of this polynomial, and I obtain this formula S6. S6 will give you the 7th coefficient of the new electrical equation. This is general formula. Whatsoever n is 3, 4, 2, whatsoever. Okay, so now we can see that we get, we will 100% or we will automatically get the value of S6, which is equal to 0. Okay, just do your own substitution and continue, of course, using Mourad Sultan Ezouidi. So this proof, not that Abel was wrong, but he, but that there is more beyond the boundary he described it. So Ezouidi theorem doesn't break the rules here. It reveals the deep structure behind them. So we can say that. Let's continue. Okay, let's continue. So try to be ready, professors, teachers, colleagues, and learning students whatsoever. Okay, who are, and those who have smart minds. Okay, so we'll do what exactly? We'll continue finding the coefficient of this differential equation. Okay, and you find that a 7 here is equal to an O. So let's dive into the structure and replace k with 8. I will obtain this is S7. Okay, S7, just make your substitution. Comes here if possible. Okay, so because that this is S7, my learners, when k equal 8, when you dive into the structure, you'll find that S7 is equal to that. This is the general formula that will give you exactly the 8th coefficient of the new 11 degree from the equation. Now we are looking for find it and solve it. So here my professors S7, it's clear, it's in front of your eyes, okay, and is equal to another. Now let's dive into the structure again and find S8. S8 just put k equal 9 in the Ezouidi theorem, and we'll obtain that 8 here is going to be equal to 0. Okay. Now, as S8 is going to be equal to 0, I'm going to extend and put k equal 10 into this theorem, and I will obtain that S10 is equal to plus 1 is equal to negative 90. Okay, equal to negative 90. So this is S9. This is the formula, the general formula to get the 10th coefficient. Now, my learning, this formula has been generalized for any nth degree from the equation. Okay. Of course, here we calculate this, and this is S9. We found that is negative 90. Okay, negative 90. Okay. So here, what's remaining? What is remaining now is finding, is diving into the structure and replace k with 11 to find S10. S10 is the 11th coefficient of the new 11 degree from the equation. So let's continue. We told that, yes, okay. We told that I'm going to replace k with what? I will replace k with 11 to get S10. When writing k equal 11, means you are going to find the 11th coefficient. Right there. So here, my learners, you can see this coefficient that colored with yellow corresponds to the coefficient of the original degree from the equation that we start with, that we challenged, that we said that we will solve this degree from the equation. And after making the solution, and after mastering the solution of this degree from the equation, I will type this on ChatGPT and DeepSeek. Both of them, they will try, but they fail. They will use method, factorization method, classical method, like Newton, like approximative, okay, like Abel theorem, but they will tell, in fact, it's not possible to solve these only to the power 11 because no one did it, okay, else except the Professor Mourad Sultan Ezouidi, who invented so many theorems that deals with the fields of mastering the solution of algebra method. So here, my professors, this S10, the formula S10, this is it's very generalized. It was generalized for any algebraic equation. Okay, so this is S10 English calculator, and do your best, and you will find that is exact. And so watch it closely, and you'll see that. Watch closely, and you'll see that the coefficient of uh, the 11 coefficient here is merged to 0. Okay. Now my learners, I'm going to make summary. Okay, so here we make summary, sorry. In other words, S0 is equal to 0, S1 is equal to 0, S2, S3, S4, S4 is different to 0, S3 0, S6 0, S7 0, S8 0, and S9 is different to 0, is negative 90, S10 is going to be equal to 0. So I should rewrite my new 11 degree from equation that has been derived from the structure of the theorem of Mr. Mourad Sultan Ezouidi. So this polynomial has to be written and then try to solve it. Okay. In other cases, you can find S1 different to you, S2 different to you, S3, S4, all the coefficients are different to you. You can find this kind of coefficient. Okay. And what is important now, uh, what is uh, what is important is that this method is not only powerful, it's a new chapter in the story of mathematics. So we can say that I will write this as x to the power 11 minus s4. S4 is minus 1 plus s9 of 42 times x equals 0. So x here equals 0, here, it's obvious. And x to the power 10 minus s4 times x to the power 5 plus s9 is equal to 0. Therefore, I will use my distinct formula. Means I'm going to consider that I have a second degree from the equation. Okay? And I will try to find the new second degree from equation that is related to s minus 1 and s0 and s1. Okay, of all the q dash, of course. Okay, so that will not be confusing. So s1 of q dash is 0 because the sum of the two x's are the second degree from equation already to 0. S minus of all the q dash is 1. So it remains only s1 of all the q dash. S1 of all the q dash is that is minus s4 raised to the power 2 plus 4 times s9. So I just make the glitch substitution. It will be negative 1, negative 361, 60, it will be negative 360. So minus s1 of OD2 is 361. Why here, my dear, uh, we put, sorry, we put minus s1. You see this coming to the power 10. I will suppose that x is to the power 2 minus s0 of order q x is to the power 1 plus s1 of order q x is to the power 0 means this one, the last term here, is s1 of order q dash. This one. Okay? So suppose this is second degree. So that's why when you solve s0 is 0 we call it. So I will write x2 minus, I will explain this for you. So that will be convincing. Okay, okay, you see this one? Change 11 by 2, change 10 by 1, change 9 by 0, and ignore the rest, Professor, if you have second degree from equation. You see S1 now, this is positive S1. X squared equal positive S1 of order dash. Sorry, x raised to the power 2 plus S1 of order R equals 0 means x raised to the power 2 is minus S1. That's why here we put a negative S1 of order 2 dash equal to 361. 361 in fact is 19 squared. So x raised to the power 5 because putting x raised to the power 5 equals capital X. We will get capital X squared minus plus S4 capital X plus S9 equals 0. So now my professors, you can see that. Yeah, okay. So we call that x5 equal s4 plus negative root of negative s1 according to that divided by 2. Therefore, x equal root of equal s4 plus negative root of negative s1 according to that divided by 2. All raised to the power 2. Exponential 2ik5 divided by 5. So I will make substitution. Means I will make what? I will make s4 with minus 1 and the root of negative s1 according to that is 90. Okay, so here I will write it as that. I just make substitution. Now the first fifth roots are minus 1 plus 90 divided by 2 raised to the power 1. Exponential 2 by divided by 19 minus 1 is 18. 18 divided by 2 is 9. So the first five roots are 9, 1 over 5, exponential 2 divided by 5. These are the first what the first 50. And here we told x equals 0, isn't it? So alpha has to be equal L0 of the cube plus 0 divided by n. Okay, this one what I mean. So alpha 11 equal L0 plus x11 divided by 11. So 1 plus 0. Why? Because we make factorization. We make x times x to the power 10 plus s4 x to the power 5 plus s6 equals 0. Okay, so we isolate this x into this x subscript 11 or this x 11. So this is a single root, okay, which is clear to you. Now the second solution is that the second fifth roots, exact roots, we can see that, and so on and so one by one the exact roots of this 11-degree equation stands before us, okay, and so one by one the exact roots of this equation of this 11-degree equation stands before us, where others so all we have carved a doorway. So this is a proof. This is a proof. Okay, this is proof. Not that. Okay, this is proof that we got exact roots, precise and exact roots. Okay, so here my professors, you can see that. Now we call that the second and fifth roots are minus 1 minus 90 will be negative 10. Divide by 2, give it negative 10. Negative 10, I will put minus 1 as exponential I5. Raised to the power of 5th will be exponential I5 divided by 5. Times this one. I have same base, so I should add the 6. Same numerator, add the numerator. So it will be 10 raised to the power 5th. Okay, exponential to k plus 1 I5 divided by 5. So now substitution these as okay. So watch closely here. The roots will emerge one by one. Each step perfectly justified. Again, I will repeat. Again, I will repeat. Watch closely. Watch closely. The roots will emerge one by one. Each step perfectly justified. Okay. This is according to the Professor Mourad Sultan Ezouidi. Okay. And if I will give this example to ChatGPT, he can do it. Okay, so I'm going now stop sharing the screen. Okay, and what is important now, my professor, is that what is important is that okay. I'm waiting for you. I'm waiting for the Wi-Fi to be connected. Then we will continue. So this is Mourad Sultan Ezouidi, the professor. Okay, explain it for you how classical method failed. Okay, and here it is not guessed, not estimated, but exact. Okay. So we call that today we made history and we showed and we demonstrated how to find exact things. Okay, okay. And now, one by one, the exact roots of this elimination equation extend before us, whereas so all we have solved very well. This is in fact is the proof, okay, how we can solve elimination equation. If classical algebra failed to find these roots, and yet they are explicit and exact, explicit and exact, then it's not the equation that we solve it, but the method that is absolute. I say the method that is absolute. For I mean classical method. Abel said no formula exists. Today I say here it is. So thank you for listening and goodbye. Now I will close this one. Thank you for listening. This is the Professor Mourad Sultan Ezouidi was with you, okay? And I explain this for you. If you want, I will, or just do your best and you do by yourself. Type the equation that I gave and do it in ChatGPT and in AI, artificial intelligence, and write this equation. He will try. He will continue trying. He will try again. He will strike, but at the end, he will tell you so you can know. Um, Next, this is how the question that can really uh, is trying to persuade you that classical method is not the most important thing because you can say that more sometimes the method of theorem is not only powerful, it's a new chapter in the study of it. And say again, Murad's method, it's not only powerful, but it's a new chapter in the field of mastering mastering the solution of any differential equation. They thank you for listening and thank you for joining. And remember, mathematics is hard secret, but we hold the field. And what I'm telling you now, I have so many books you can go through and buy them will be benefited from my research. Thank you and goodbye. This is me, Super Beauty, the playing with the necklace, and the one who challenged it, who defied and challenged it, let's say, to dive into the field of mathematics, especially in mastering